my TTL computer. Today we're going to take a look at two applications I put together for my TTL computer. And the first, we're going to revisit the Fibonacci sequence that we did some time ago in our videos, where we keyed that into the computer. And I think the highest number in the sequence we could see was 89, and then it overflowed the two-digit display. So we'll see if we can do a bit better than that today. Okay, I just ran that through the assembler, and we see that our Fibonacci program took 130 bytes. Okay, so now we want to transfer that up to my TTL computer. And that is going. And just a reminder that each of those dots in the send file is a successful send, byte send to my TTL computer. If there was an error, we'd seen X, but hopefully we won't see that. They do happen, and it does recover. Sometimes it does not. Should be completing pretty soon, and then the program will start immediately following the upload. There we go, Fibonacci sequence. Okay, and then we have our sequence going. All right, so a reminder, we're running on an 8-bit computer here, so our sequence is going to run from 0 up until as far as we can go in 1 byte, which is 233. And so you see that sequence is going. So just some interesting things to note with this program is that one of the key things that we're doing, the actual procedure for generating a Fibonacci sequence is pretty simple. It's just an addition of two terms, the last term and the current term. So that's pretty straightforward. So the most complicated thing we're doing in this program is converting that binary sum to a decimal value, right? From the hex to the decimal is the hardest thing we're doing. So something else interesting to note, watch how fast the numbers go as they're smaller, and you'll notice it gets slower and slower as the magnitude of the number increases. And the reason for that is that we're doing a successive subtraction to convert that binary number to decimal values. And that's because of limitations in the instruction set. I can do the bit shifting that I need to do, but I don't have any way of masking off any bits in a byte. And because of that, I basically need an AND statement. Because I don't have an AND statement, I have to do this method of these successive subtractions to convert from the binary to the decimal equivalent of the number. Just something interesting to note. Okay, so that's our Fibonacci sequence. All right, let's stop that. Okay, the next program we're going to take a look at is a high-low program. And I actually had done a high-low program early on, but I don't think we ever did a video about it. So this will be a little bit new, but all right, so let's get the high-low program. I'm going to assemble this, and this is pretty large, 185 bytes. We have 16 bytes remaining. So this uses quite a lot of the memory in the computer. All right, I'm going to get ready to transfer this up. And we're ready. And we're transferring that up to computer. So this is a really basic program where the computer basically comes up with a random number, and our goal is to guess the number. And we put in our guess, and the computer will tell us whether we're too high or we're too low, and we get to guess again. So this is a really trivial program, usually, and something that every beginning programmer is maybe one of the first programs they develop to increase their programming skills. Okay, so this is uploaded and we're ready to go here now. All right, so what's this thing doing here with begin? So with any high-low program, we need to start from a random number because the computer needs to have a random number. So that's what we're actually doing here, is it's asking us to enter, press a key, and that is going to seed the random number, if you will. And we can really use any key on the keyboard and to do that. So I'll just pick one. All right, so now we're entering our guess. So again, we're working on a 1 byte computer system, so that our possible values are going to be between 0 and 255. And it's become evident as I've started to make some of these programs that we have to make a lot of compromises in our programs because just 256 bytes is not a lot of working memory, especially when you have a reduced instruction set. So we have to input 3 digits for our guess. So we will start with 128. All right, we have to go higher. So let's go to 196, higher, 225, lower, 215, lower, 200, 210. Oops, missed. That was my mistake. 210, lower, 208, lower, 205, 204, okay, 203, nice, 202. All right, we got it. So I don't have enough memory to tally up how many guesses it took you to do that, but that's usually something we have in our program. So we're back to the beginning here, and we can enter a new random number seed, and I'll do P this time. So this again looks like a really stupid program to play. It's oddly satisfying to play. I don't know why. It's so stupidly simple, but it is, and it's kind of like, you know, there's a procedure that you follow. You keep having your numbers, you know, as you go for your next guess. But all right, so we have to go lower. Where are we at? 215. It's funny that it is funny. It's fun to play for some stupid reason. I think this is it. No, what am I doing? I did something wrong. What did I do? Huh? I must have messed up. What happened? I should have been going higher before. Okay, I screwed up. There we go. All right, so that's our high-low game. A little bit probably boring to watch, but it's oddly enjoyable to play. I don't know why. Okay, so yeah, let me see. Anything interesting to just point out in the program here? Um, yeah, the converting the numbers. You know, again, so now we're converting here. We're converting from decimal to binary, right? Because we're entering decimal. Our guesses are in decimal, and we have to convert them to binary. So we use a lot of our program space uh, just to do that conversion. And the same is true of the Fibonacci sequence. We use a lot of the program space just to do the binary to decimal conversions. So I'm not going to really look at these programs, but hey, that's it. Just a quick video. So our next video is going to kind of be our finale on our of our applications, and that's something I've been working on for a couple of better part of a week or a little bit longer. But I think it's really cool what I've been able to put together for us, and it's going to give you the opportunity to participate. So that participation window is going to be a week's the week following when that video goes live. So you're going to want to watch for the next video to come out. It's going to be our finale video, and then we'll have a final wrap-up video for the series. And that's going to be, it's going to bring this series to its conclusion. So, hey, I hope this was a good, enjoyable series for you. Fun to look at these little applications. And yeah, that's it. Thanks for watching.